We are from Group 1. I'm Uisihan. My metric number is 310324. We will present our group assignment 2 for Introduction to Mathematical Economics, which under a system of simultaneous equations. The given question is, consider the following national income model: Y equals to C plus IO plus GO, C equals to CO plus BYD, T equals to TO plus TY, where Y is aggregate income, C is consumption, IO is autonomous investment, GO is autonomous government purchases, YD is disposable income, which is defined as YD is identically equal to Y minus T, where T is income tax, CO is autonomous consumption, TO is autonomous debt, and B and T are parameters such that B and T are elements of the open interval 0, 1. We need to form a system of 3 simultaneous equations in 3 endogenous variables, which is Y, C, and T. The following national income model is Y equals to C plus IO plus GO, C equals to CO plus BYD, and we know that YD is identically equals to Y minus T. T equals to TO plus TY. The endogenous variables is Y, C, and T. When we want to build a metric form, we need to follow sequence, which is Y, C, and then T. If doesn't have any one of it, we will define it as 0. From Y equals C plus IO plus GO, it doesn't have T, so we need to plus 0 as the T. We can get Y minus C plus 0 equals to IO plus GO. Our first simultaneous equation is Y minus C equals to IO plus GO. Secondly, we write again C equals to CO plus B, Y minus T. B times Y equals to BY, B times negative T equals to negative BT. So C equals to CO plus BY minus BT. Now we need to arrange it followed by the sequence, which is Y, C, and then T. We need to bring which have Y, C, and T to the left hand side. So negative BY plus C minus BT equals to CO is the second simultaneous equation. Thirdly, from T equals to TO plus TY, we bring again which have Y, C, and T to left hand side. It will become negative TY plus 0 plus T equals to TO. So the third simultaneous equation is negative TY plus T equals to TO. That's all for question A.
My name is Pei ID. My matrix number is 310370. And now I'll be talking about part B, which is transform the above 3 simultaneous equation into the matrix form. So I use the A times X equals to B formula. A is the matrix of coefficient, X is the vector of variable, and B is the vector constant. So under A, for the first row, we have 1, negative 1, and 0. Second row, we have negative B, 1, and B. And the third row, we have negative T, 0, and 1. And then this matrix of coefficient will times into the X, which is the vector of variable, which consists Y, C, and T, equals to the vector constant B. The first row is IO plus GO, and then the second row is CO, and the third row is TO. Moving on, C, solve for Y, C, and T using the matrix inversion method. So first, we will find the determinant of A, which I get determinant of A equals to 1 minus B times 1 minus T. So with this, we know that the determinant of A is not equal to 0. And next, we will find the inversion of A. So we use the formula A inverse equals to 1 over determinant of A times adjoint of A. So we will start finding our matrix inversion for Y, C, and T. So we will use the formula x equals to inverse of a times b. So x is our variable, which is y, c, and t, equals to our inversion of a, and b is our vector constant. So now we will solve for y. So y, we will take the coefficient of the first row of the coefficient and the first row of the constant, and then we will get y equals to io plus go plus co minus bto over 1 minus b times 1 minus t. And for c, we will take the second row of the inversion of a, and then the second row of the vector of constant, and we will get c equals to b times 1 minus t times io plus go plus co minus bto over 1 minus b times 1 minus t. And lastly, for t, we will take the last row of the inversion of a and the last row of the vector of constant, and we will get t equals to t times io plus go minus t times co plus 1 minus b times to over 1 minus b times 1 minus t.
My name is Suja En. My matrix number is 310650. Now I will talk about the part C, solve the y, c, and t using the Cramer rules. So firstly, we will replace the first row of y with b to find the determinant of a sub y. So we get the first row io plus go, negative 1, 0, and the second row is co, 1, b, and the third row is to, 0 and 1. After that, we will get io plus go multiplied by 1 plus negative 1 multiplied by co minus bto. Then we get the answer io plus go plus co plus bto. Then after that, we will solve for y using the determinant of a sub y divided by the determinant of the original matrix. We get io plus go plus co plus bto divided by 1 minus b multiplied by 1 minus t. Then after that, we will solve for c. Firstly, we will replace the second row of c with b to find the determinant of a sub c. Then we get the first row 1, io plus go, 0, and the second row negative b, co, b, and the third row negative t, to, and 1. After that, we get 1 multiplied by co minus bto minus io plus go multiplied by negative b plus bt. We get the answer co minus bto plus b multiply 1 minus t multiply io plus go. Then now we will solve for c using the determinant of a sub c divided by the determinant of the original matrix. We get co minus bto plus b multiply 1 minus t io plus go divided by 1 minus b multiply 1 minus t. After that, we will solve for t using the Cramer rules. We will replace the third row of t with b to find the determinant of a sub t. So the first row is 1, negative 1, io plus go. The second row is negative b, 1, co, and the third row is negative t, 0, and to. After that, we get 1 multiplied by to minus negative 1 multiply negative bto plus co plus io plus go multiplied by negative t. Then we get the answer to multiply 1 minus b plus t multiply co plus io plus go. After that, we will solve for t using the determinant of a sub t divided by the determinant of the original matrix. We get to multiplied by 1 minus b plus t multiply co plus io plus go divided by 1 minus b multiply 1 minus t.